Howdy guys, this lesson is going to be a continuation of what we did in class today, September 17th or September 18th, depending on what day of the week you have me. We might have gotten to this number 5 in class, so if we did, just bear with me as I work through it again. I obviously wasn't sure how far we'd get in class, so I wanted to cover this just in case. So we've been working on solving literal equations today. And to solve a literal equation, you need to know how to isolate different variables. So we know literal equations have more than one variable, and we need to be able to rearrange problems and rework them to isolate or get any variable in the problem by itself. So here we have the formula for distance. This is a formula that you will see in physics. And it is distance equals rate, that's like the speed, times time. So how long did it take? Okay, but we have been talking about we don't always want to solve for distance, right? We don't always want to solve for D. So what if we know we want to run 2 miles and we know we run 5 miles per hour? So how long would that take? That would be we're solving for time. Right? So in the real world, you're not always solving for the variable that is isolated, that's by itself. You might be solving for one of the other variables depending on the information, depending on what you're trying to solve for. So you have to know how to isolate any variable in a problem. Okay? So in this example, we're not actually putting specific numbers in here. That's not what the unit is about. This unit is truly about can you manipulate and rearrange and balance equations to solve for any variable. Okay, we will end up putting numbers in. We will end up solving for actual values of things. But today we're just focusing on how do we isolate any of the variables. So in this equation, let's solve for T, which is time. Okay, so we're going to solve for T, which is time. So that means this T, it needs to be by itself. It needs to be isolated. Okay, so we were reviewing this at the beginning of the year. So remember I told you that was going to come back into play? Well, here it is. I need to isolate this T. Well, to get it by itself, to isolate it, I have to get rid of this R. The R has got to go away. I don't like it. Okay, and remember in math, if we're trying to get rid of something, we do the inverse operation. That means the opposite kind of math to get rid of it. So I can see that that R is being multiplied by T. So to get rid of that R, I do the opposite, the inverse, which is divide by R. Because the whole goal is I want them to cancel out. But we know in math, if we do it on one side, we have to do it on the other. Okay, so we have D, remember that's distance, over R, which is our rate of speed, equals, your R's canceled out, and T for time is now all by itself. It's isolated. Okay, and that's it. We don't have any numbers. Remember, we're not actually solving today. We're just practicing isolating today. And so you're done. Now, instead of solving for distance, like it said in the original equation, we manipulated it or changed it to solve for T. Okay, so let's look at a different formula. So here we have volume of a cylinder. So remember, a cylinder is a can. Okay, so volume is the amount of substance something would hold. So here we have a cylinder, a can, and if we're trying to find the volume, we want to know how much air, how much gas, how much liquid, how much solid would fit in that can. Okay, But maybe you don't always want to solve for volume. Maybe volume is not always what you want to solve for. Maybe you want to solve for the height, right? Maybe you know how much liquid you want to put into something, but you need to know how tall the can needs to be to hold that much liquid. Okay, so in this example, we're going to solve for height. So I'm going to put solve for H. So maybe we know the amount, maybe we know the volume, and maybe we know the radius, so we know half the distance of the circle at the bottom of the can. But we need to know how tall does the can need to be to hold all the volume, hold all the liquid, hold all the solid, whatever we're dealing with. Okay, so I see that this H is being multiplied by pi and by r squared, right? I know they're being multiplied because they're all right next to each other. There's no symbols or anything between, so I know they're being multiplied. So to get rid of that, to get rid of multiplication, something being multiplied, I do the inverse, the opposite, which is division. Okay, so if I want to get rid of, and if it helps you, you could put all of these in parentheses, if that helps you see it a little bit better. So I want to get rid of pi and the r squared. You could do them one at a time, or you could try to do them both together. It doesn't matter. But if you divide something on one side, you have to divide on the other. Okay, so now we have our volume over pi r squared. Remember, if it helps you, put it in parentheses. That's great. That's fine. On the right-hand side, your pi's cancel out. Your r squares cancel out. And we're left with h. Maybe I should move my equal sign. There we go. So now I took that problem that the way we are given it is that we're solving for V, for volume. That's what was isolated. But depending on the information you're given or the information you know, now we know how to solve for H. We know how to solve for the height. Okay, so if you feel really confident in solving for variables, this stuff is probably not too challenging for you. But if you have trouble solving for variables, this might be a little bit harder, right? Because it takes a lot of thought and work into, okay, what do I need to do now? How do I get rid of this? How do I get rid of that? Okay, let's look at another one. So here we have a box, which is a rectangular prism. Okay, and the volume, so how much this box is going to hold, you would multiply the length of the box the width of the box. Oops, you can't really see that. The length. There we go. The length of the box, the width of the box, and the height of the box. Okay, and then you can figure out how much would this hold. What's the volume? But what if we don't want to solve for V? What if we don't want to solve for the volume? What if we know the volume and we know the length and we know the width, but we need to know how tall the box is? We might be solving for H, right? So depending on the information you're given in the problem, that determines what variable you're going to solve for. So let's solve for the width in this one. So let's solve for the width, which would be W. So if I want to solve for W, I can see there's an L for length and an H for height on the same side. That means those two things have to go away. Okay, I'm going to break this one up. That previous problem, I divided by two things at the same time. This one, I'm going to divide by one just to show you the difference. Okay, so I can see, and if it helps you, you can put the length, the width, and the height in parentheses. That's your choice if it helps you. Okay, so I'm going to just get rid of the L this time. So I'm going to take it step by step. Instead of getting rid of the L and the H together, I'm going to just get rid of the L in case this way kind of helps you more. So I see that the L and the W are being multiplied. So to get rid of something, we do the inverse operation, the opposite kind of math. So if they're being multiplied, to get rid of that L, I'm going to divide. But if I do something on one side, and if you need to make it a capital L just for right now so it looks like an L instead of a 1, you can do that. If I divide on one side, I have to divide on the other. Okay, so now we have V over L. Your L's cancel out and you're left with WH. Okay, well, I'm solving for W, and I see that it's being multiplied by H. That means that H has to go away. And the way we get it to go away is by doing the inverse operation, the opposite kind of math. So if it's being multiplied by H, I'm going to divide it by H. But if I divide one side, I have to divide the other. Okay, so we're left with V L times H, or you could put them in parentheses, or you could just put them right next to each other, right? That's all the same thing. And then on the right side, your H's cancel, and you're left with W. So now, if we know how much the rectangular prism, the box, would hold, we know the length of the box and the height of the box, we could find the width. Okay, so literal equations, it's all about being able to rearrange and manipulate variables to solve for one of the variables that may or may not already be isolated. All right, let's do this last one because it has a fraction. This is the formula for area of a triangle. So area of a triangle equals 1/2 base times height. Okay, so if I knew the base of this triangle and I knew the height of the triangle, then I could solve to find out the area. So I could solve to find out the area. Right? That's what that triangle is saying. But what if I'm given the area and I'm given the height? I could solve for the base, right? So you're not always solving for the variable that's already by itself. It's already isolated. Sometimes you're solving for one of the other variables and you have some manipulating or rearranging to do. So let's solve this equation for B. Okay, that means if we're trying to solve for the base, the b, that means you actually have to get it by itself first. You have to isolate it. Okay? And I see two things in the way. I see this 1/2 and I see this h. And I see that that b is being multiplied by 1/2 and h. They're all right next to each other. I know that means they're all being multiplied. But if you have a little bit of trouble with fractions, let's try to deal with that fraction last. Okay? So what I'm going to do first is I'm going to try to get rid of that h. And there's a couple different ways you could solve this. So if you see a different way that works for you, do a different way. Okay, so I see that the b and the h, they're being multiplied. So I'm going to get rid of that h by dividing, because that's the inverse operation, the opposite kind of math. But if I do it on one side, I have to do it on the other. Okay, so I am left with a over h equals, we have 1/2 times b, because our h is canceled out. Okay. All right, so remember back to when we were reviewing and we were multiplying by a fraction, and that is a little confusing because to divide by a fraction, that looks a little overwhelming, right? So we said instead of trying to divide to get rid of fractions, we can actually just try to eliminate or cancel out the denominator. Okay, so the way you do that, let's say you want to get rid of 1/2. The way you do that is by multiplying by its reciprocal. The reciprocal is when your numerator and your denominator switch positions. They flip. So another example, if you had 3/4 and you wanted to eliminate that fraction, you would multiply by its reciprocal, which is 4/3. So to cancel out fractions, you multiply by its reciprocal. All right. So I'm going to multiply both sides by 2/1. Or if it helps you, if you want to put that 2/1 right next to the 1/2, you can. Okay. But if we do something to one side, we have to do it to the other. Okay, so over on the left, we have 2 times a, which is 2a, over 1 times h, which is 1h, which is really just h. On the right-hand side, your 2's cancel and your 1's cancel, and we're left with b. Okay, so remember to get rid of fractions, even though that 1/2 and the b were being multiplied. To get rid of a fraction, it's easier to multiply by its reciprocal, where you flip or reverse the numerator and the denominator. Okay, so everything we've done so far, we have identified literal equations, so they have more than one variable. We most often see them with formulas, but we're putting real values in place of the variables. But the biggest thing we need to know with literal equations, we need to know how to solve for any of the variables that are in the equation.